Hello everybody, Xavier Velez here, coming to you to do another experiment today. So we're going to be working on making a fireproof balloon. I've taken a look at a video, kind of read up on a couple things, and we're going to get ready to do this experiment. But before we do this experiment, what I'm going to do is give you just some background information on what exactly we're doing here. So as you know, balloons are some of the best things ever when you're a kid and even when you're an adult. But among that, they are probably one of the most fragile things that we have to deal with. So they can make you the happiest kid in the world and make you the saddest kid at the same time because they pop so frequently, and half the time you don't even know why it's popping, but it stinks. So anyway, we know keep them away from sharp objects, keep them away from fire, keep them away from anything that's gonna potentially damage or compromise the balloon itself, right? Because it's already stretched out and it takes almost nothing to just make it go pop. Okay, so anyway, so you keep it away from fire. Most of the time it's sharp objects, but in this particular case, fire, right? Balloons don't survive in fire at all. Fire weakens rubber. The rubber is already compromised and it will just pop instantly. And so in this experiment, what we're gonna look at is we're gonna place a fire to a balloon, and then we're going to see what happens, right? And our hypothesis is that this thing is just going to pop instantly with the heat. And we'll see if we can make that happen. But let's first discuss thermal conduction, okay? So thermal conduction is the ability of an object to allow heat to be transferred and conducted through it, right? Heat always travels from a hotter spot to a cooler spot, right? So it likes to be transferred pretty quickly. It's always going to be looking for that somewhere else to go. So thermal conduction exists in solids, liquids, and gases. The conduction of heat through a medium happens because the particles in the medium vibrate or move faster than the heat that's applied to it. And the vibration movement of the particles will start at the point where the heat originates. As the particles' energy and vibration increase, they will collide with neighboring particles and transfer thermal energy to them, okay? So what we're gonna do is we're gonna take two balloons. We're going to inflate one with air and one with water and see what happens. Ideally, the one with air is going to pop because the heat is going to be directly placed to the rubber of the balloon, compromising it and popping almost instantly because the rubber is going to be taking the heat. Whereas when we inflate the one with water, the water is going to be absorbing the heat, thereby allowing the heat to actually not directly impact and compromise the rubber so much, and lasting a whole heck of a lot longer than the one that's just filled with air. So we're going to test this out, see if it works, and go from there, okay? All right, everybody, we're going to get ready to start the first part of our experiment here. We're going to apply heat to our balloon, and we're going to see what happens. What should essentially happen is the heat should go directly to the balloon, the latex to the balloon, and it should pop because it won't be able to withstand and disperse the heat from the flame. Okay, so let's see what happens real quick. Here's some fire, and boom. Balloon is popped. Okay, that was as we expected. Not too bad. Next up, we have our balloon with some water in it. So let's see how this works out. Ideally, what should happen is that the water should be able to disperse the heat, thereby taking it away from the balloon itself and last longer. So let's see what happens. And look at that, no poppage of balloon. All right, there you have it. The experiment has proven to show that the water displaces the heat better, allowing the balloon to not pop.